Hey guys, this is Mr. Grice for Algebra 2, Chapter 7.6 Notes, Day 2. Today we're continuing our discussion on application of quadratic equations. Our learning target today is to be able to solve the quadratic equations involving the Pythagorean theorem. So, the Pythagorean theorem. Let's review. Remember that is a squared plus b squared equals c squared. And in your triangle, A and B are always going to be the legs, and C, which is the hypotenuse, is always across from the right angle. Okay? So for number A, it says use the Pythagorean theorem to find the missing length. So if you want to go off to the side, you can say, well, A is 4, B is 3, and C, that's what we're trying to find. Okay? So we know these are our legs. So a squared plus b squared equals c squared. We're always going to put the number inside the parentheses. And that's just going to help us out for some of the new problems that we're going to be doing. So 4 squared is 16. 3 squared is 9 equals x squared. 16 plus 9 is 25. And to get rid of the exponent, we take the square root. So the square root of 25 is 5. And that's what the missing length is. Okay? Now for B, we're doing the same thing. Just make sure you can see which ones are the legs and what's the hypotenuse. Okay? So for this one, they tell us it doesn't matter if it's A or B, where you put the x, but the C is 13. So we have 5 squared plus x squared equals 13 squared. And I want you guys to pause the video and see if you can figure this one out. All right. Good luck. Okay, and there's the answer. So 5 squared is 25, x squared is x squared, and 13 squared is 169. And just follow the rules of SADMAP by subtracting 25 to both sides and then taking the square root. Alrighty. Now, Pythagorean theorem application of quadratic equations. Find the dimensions of the triangle below. Now, the only thing that's different now is instead of giving us what everything is, we have a bunch of variables. So, key thing is to know what your legs are, and then what's the hypotenuse. And now we're going to use the Pythagorean theorem to solve this. Okay? So we have x squared plus x plus 2 squared equaling x plus 4 squared. So we have x squared. Remember that the square tells us how many of the bases we have. So what it's really telling us that inside of that, it's x plus 2 times x plus 2. And over here, it's x plus 4 times x plus 4. You need to know how to FOIL. Okay? So we get x squared plus x squared plus 2x plus 2x plus 4. Like, all right, we did it once. but we got to do it again. X squared plus 4x plus 4x plus 16. Okay? Now that we've done that, we're going to look for our like terms on each side so we can combine them up. And over here, we've got some like terms too. So we get 2x squared plus 4x plus 4 equals x squared plus 8x plus 16. So now we need to determine what's our leading coefficient. Okay, we have two choices. We have the 2x squared or the x squared, because those are the highest exponents. Which one is bigger? The 2x squared is, so that means everything on the right we need to move over because we want one side equal to 0. All of those cancel out, and we get x squared minus 4x minus 12 equals 0. Okay, and now that we have one side equal to 0, we can go down and factor that. Okay, so you are looking for numbers that add up to get to negative 4 and multiply to get to negative 12. Right? The group that works is 2 and negative 6. So you get x squared plus 2x minus 6x minus 12 equals 0. Okay, and from there, you're going to need to factor. And we're going to do the box method. So you get x squared plus 2x minus 6x minus 12. Take the GCF of the top, which is x, the GCF of the bottom, which is negative 6, the GCF of the left, which is x, and then the GCF of the right is positive 2. And the nice thing about that is that gives us our two binomials, the x minus 6 and x plus 2, excuse me, equals 0. So we know that x equals 6 and x equals negative 2. Now, when you plug that in, we can't have a negative length, so that's why the negative 2 doesn't work. And now the thing that we're looking for is what are the lengths. And you would plug in 6 to all of those and get your answer. So these side lengths are 6, 8, and 10. Okay, so guys, this is a lot of work. You need to know how to FOIL. You need to know how to factor. All of that stuff, okay? So it's very important. If you don't know how to do this, you need to come in for help. All right, let's look at example number 2. I'm going to find our two legs. And there's the hypotenuse. So we have 2x squared plus x minus 1 squared equaling 2x plus 1 squared. Okay? So we're going to break this down. so we can see what it would look like. So that's going to be the blue, that's going to be the yellow, and there's the gray. Okay, so this is 2x times 2x plus x minus 1 times x minus 1, and 2x plus 1 times 2x plus 1. Okay. So we need to figure out what we're going to get in all of those things. Like, wait, what do all those equal? Well, that's where we have to distribute and FOIL. Okay? So in the yellow, 2x times 2x, well, that is 4x squared. Okay, so we got that. Well, now we need to FOIL, so we get x squared minus 1x minus 1x plus 1 equaling, and we got to do the same thing over here. 4x squared plus 2x plus 2x plus 1. Okay? Go ahead and combine your like terms on both sides. Which are those guys and those guys. So we get 5x squared minus 2x plus 1. And then on the right side, we get 4x squared plus 4x plus 1. Take a look. And which one is the leading coefficient? 5x squared. Okay? So we have to subtract everything on the right to the other side. So we can get everything equal to 0. And when we do that, we get x squared minus 6x, because our 1's cancel. And to factor this, all we have to do is take out the GCF, which is the x. Okay? And then we do that, we get x equaling 0 and x equals 6. We can't have a length of 0, so plug in 6 to everything. And then that's where we're going to get our answers. Okay? Our side lengths, we get 5, 12, and 13. All right, number 3. What I want you to do to number 3 is just go ahead and set it up and see if you can get the first couple steps all by yourself. Look at your other problems for examples, and good luck. Okay, so that's how it should be when you're all set up. Now, I got everything down to where we're looking for the leading coefficient. Okay, and those are the two that we get to choose from. The 2x squared is bigger, so we're going to subtract the x squared to the other side, the 40 to the other side, and the 400 to the other side. That way we get one side equal to 0, and we're left with x squared minus 20x minus 300. Okay, so we need to find out what numbers let me rewrite that. That add up to negative 20 and multiply to negative 300. Since there's no GCF, that's what we got to deal with. Okay, now, do you really want to sit here and do all of the factors of 300? You're going to be there for a while. okay? So you need to know your times tables, and you need to know how to use that multiplication chart to help you out, okay? Because once you break it down, you end up getting 10 and negative 30. Okay, so we get x squared plus 10x minus 30x minus 300 equals 0. Okay, and I'm going to pause the video again because you guys should be able to factor and solve that. Okay, good luck. Okay, now if you can tell, I did the box method over here, so you can see exactly how we factored that out. We can't have a negative 10 length, so x is 30. And then that's how we get all those answers. Okay, so you plug in 30 over here by your triangle, and that's how we got those numbers. Now, if you have any more specific questions or you need further assistance, please come see Ms. Carranza or myself. Otherwise, that's going to be it for Algebra 2, Chapter 7.6 Notes, Day 2. Thanks for watching.